Hi everyone, I am Stephanie Grace Pisiton and this is about spherical geometry. This is an example of a spherical triangle with three right angles. Let's define spherical geometry. Spherical geometry is one type of non-Euclidean geometry. Spherical geometry is a system of points, great circles, and spheres. Most of spherical geometry was developed by early Babylonians, Arabs, and Greeks. Their study was based on the astronomy of Earth and their need to be able to measure time accurately. Next is we need to compare a spherical geometry and a plane Euclidean geometry. In the plane Euclidean geometry, there is a unique line passing through any 2 points, while the spherical geometry, there is a great circle passing through any pair of non-polar points. In the plane Euclidean geometry, a line goes infinitely in 2 directions, while in spherical geometry, a great circle is finite and returns to its original starting points. In plane Euclidean geometry, if 3 points are collinear, exactly one is between the other 2. While in the spherical geometry, if 3 points are collinear, any one of the 3 points is between the other 2. A is between B and C, B is between A and C, C is between A and B. And in the plane Euclidean geometry, a line segment is the shortest path between 2 points. While in the spherical geometry, an arc of a great circle is the shortest path between 2 points. Let's proceed to the Euclidean versus spherical fact. In Euclidean fact, 2 lines intersect 1 point and form 4 angles, while in the spherical fact, 2 lines intersect at 2 points and form 8 angles. In Euclidean fact, through a point not on a line, there exists one parallel line, while in spherical fact, no parallel lines exist in spherical geometry. In Euclidean fact, perpendicular lines form 4 right angles, while spherical fact, perpendicular lines intersect twice and form 8 right angles. And in Euclidean fact, 3 non-collinear points form a triangle. It's the same as in the spherical fact, 3 non-collinear points form a triangle. And in a Euclidean fact, triangle sum is 180 degree. While in the spherical fact, the triangle sum is greater than 180 degree but less than 540 degree. In Euclidean fact, a triangle can have at most one right or one obtuse angle, while in the spherical fact, a triangle can have more than one right or obtuse angle. In Euclidean fact, each angle of an equiangular triangle measures 60 degrees, while in the spherical fact, the angle measures of an equiangular triangle can vary. Real-life application of spherical geometry is on a globe. Lines of longitude are great circles. See how this line of longitude kind of comes around at the widest point it goes around in the backside of this sphere. So your lines at longitude are great circles, but your lines at latitude are not great circles because they don't go around the widest point the equator does. So if you picture the equator, that's a great circle, but these other lines of latitude are not great circles. One application of our spherical geometry is when we are talking about traveling. If I'm traveling and try to find the shortest way to get from one location to another, that's going to be an arc on the surface of our sphere. It's obviously not going to be a straight line, because if you try to travel in a straight line from say Chicago to London, you're going through the planet Earth, right? We actually have to travel in arcs everywhere. So as far as travel, there's a ton of application of spherical geometry.